All right, welcome to this fabulous edition of Comet Algebra. Today we're looking at section 11.3, Basic Trigonometry Identities. So this is where the best way I can describe it is algebra and trig are brought together and you're using all your algebra skills to substitute and manipulate and work with these trig identities. So start with the definition. An identity is an equation that is true for all values in a domain. So these identities, they work for everything. A simple example of an identity that you may have learned earlier in your math career, if you take the number 1 and you multiply it times any number x, you get that number x. So that's an identity is always true. So these trig identities are used in science to solve questions, solve problems involving forces and vectors, objects moving in a circular path. I'm not going to do those examples in this video. Before we can solve those problems, we need to learn this new type of algebra and dealing with these. So that's what we're going to focus on. All right, you have been given a pink sheet with the trig identities on them because I would never expect you to memorize all this. So just read over the reciprocal identities. They should be very familiar to you from our last chapter. These are just definitions of what cosecant is defined to be the 1 over sine. So these first one comes from definitions. These quotient identities, we will be verifying them. In other words, we're going to prove that these are true. And the same with the Pythagorean identities. You can kind of tell from the name that they do come from the Pythagorean theorem, and we're going to be verifying those as well. Verifying means we're going to prove that they really are identities. We're going to show that they are true always. And verifying isn't a formal proof. It's more just using algebra to show that one side does equal the other. For our first example, we're going to verify one of the quotient identities that says tangent is sine over cosine. So I've drawn a triangle over here, kind of like from the unit circle, where we have, over x and then up y, and then we have the radius. And we're going to use some definitions to solve, or rather to verify this identity. And I see that I have sine and cosine in the identity, so I believe I'm going to need those definitions. So let's just use this triangle to write the definitions of the sine of theta. So sine is opposite over hypotenuse, so sine is y over r, and cosine of theta is x over r. So now the strategy is going to be, if we start working with this sine over cosine, and we do some substitutions, and we use our algebra skills, and we work through this, and hopefully we can show that we start with this, and we end up with tangent. And if we do that, we can say that we have verified the identity. So like I said from the triangle, sine is y over r. So let's substitute where the word sine is. Let's put y over r. So that's the numerator of the fraction. Cosine is x over r, the denominator. And this compound fraction can be simplified. We know that when we're dividing fractions, we don't divide them. We multiply by reciprocal. So if we multiply by by r over x, the r's would cancel, and I'm left with y over x. And you may think, wow, big deal, where did that get me? Well, let's go back to the triangle and look at our goal. What we're trying to reach here is tangent. So perhaps I should have wrote down the definition of tangent also. Tangent of theta is opposite over adjacent, which is y over x, and that's what we ended up with, y over x. So we can make that substitution. Y over x is tangent of theta. So we have verified the identity. We started with this part, and we ended up, using our algebra skills, we ended up with tangent, so this identity is verified. In this next example, we're asked to verify sine squared plus cosine squared equals 1. So once again, we're going to use the strategy here. We're going to start with this side. We're going to do some substitutions and some algebra, and we're going to see if we can end up with a 1. So once again, I've drawn this triangle to look at, written down some definitions. Sine is y over r, so let's do this substitution here. Let's put in y over r, and since this sine is squared, I need to square my ratio here, plus x over r, quantity squared. And we learned in the chapter on exponents, if you're squaring something in parentheses, you have to square all the factors. So this is the same as y squared over r squared plus x squared over r squared. And now this is where you just have to kind of notice things. Notice that we do have common denominator here, so we can add these. And I'm kind of weird in OCD, so I'm going to put it in standard form. I'm going to put the x squared first, plus y squared, and this is over the common denominator of r squared. Now here is where we may get stuck, and we just have to look at what we have here and try to recognize something. And I'm going to come over back to my triangle here, and because we have an x squared and a y squared over there in our fraction, let's look at this triangle from that point of view. What is x squared plus y squared on this triangle? And hopefully you notice that that is the beginning of the Pythagorean theorem. It just has to be something from our creative part of our mind and our memory. We just have to start seeing these things, and the more you work with trig identities, the more things you will see. So if we notice that x squared plus y squared equals r squared, this gives us a wonderful substitution. We can come back over to our fraction where we have x squared plus y squared. We could put in the r squared, and r squared over r squared is 1. So you have verified this identity. You started with this side, and we ended up getting to a 1. So that trig identity is verified. Now sometimes in your assignment, you will be given what you start with, and they'll tell you what to end with, and then you fill in the middle. And sometimes they just say simplify. When it says simplify, what you're going for is just to do some substitutions and simplify it down to a single trig function, like cosecant of theta or negative cosine. And sometimes it even simplifies down to a 1. So there's always some hints in these if you know what to look for. So I'm seeing this multiply sign here in the first example, secant times cotangent. If you're going to do any simplifying, we're going to have to find some canceling so we can simplify this from 2 trig functions being multiplied down to 1. So you need to have your pink sheet sitting there, and you need to sort of be planning ahead and looking for a substitution that could possibly lead you to some canceling. And it's okay to try something and get a dead end and then start over. So if we notice that secant is on the reciprocal identities is 1 over cosine, let's make that substitution. And so now that we have a cosine, we're kind of looking for a way that we could cancel it. And if you notice that cotangent in the quotient identities is cosine over sine, you have set yourself up very nicely to cancel the cosines. So now you may think, I'm done. I have 1 over sine theta. But this can be simplified even more, because 1 over sine theta is cosecant. And now you're done. You have simplified it down to a single trig identity. So let's look at the second example. When I look at this, the first thing I notice is this plus sign. And whenever I see a plus sign, when I have to simplify a trig identity, I look at the pink sheet and I notice that the Pythagorean identities also have plus signs in them. So it's very likely that we're going to be going towards one of those. So let's think in terms of that. And in the Pythagorean identities, all of the trig functions are squared. So I want to try thinking of some substitutions I can do here that may lead me to having like a sine squared or a cotangent squared or something like that. So if I notice that cosecant is 1 over sine, and I already have a sine in this, let's try that. Let's leave sine of alpha in our numerator, but let's put in our denominator for the cosecant, let's put 1 over sine alpha. And let's see if we can, since I have two sines here, it's going to lead me to sine squared. Let's try to get another cosine in the second fraction, because I can see I could be heading towards that first Pythagorean identity. Secant is 1 over cosine, so make that substitution. And then we know in this compound fraction, we're not dividing, we multiply by the reciprocal. So this becomes sine times sine, which is sine squared of alpha, plus, same thing here, cosine squared of alpha. And that is the first Pythagorean identity. Sine squared plus cosine squared is 1. So simplified down, the answer is 1. All right, in example 3, again, looking for some clues to figure out what direction to go. I see a minus sign, and I see a sine squared. So this reminds me very much of the first Pythagorean identity, sine squared plus cosine squared equals 1. So let's see if we can do some work over here on this side and possibly get to a cosine squared, because that might lead us to that identity. So I'm going to leave the sine squared alone for a minute. And please remember, I could be wrong. These are just guesses. One of the students in class described this as guess and check, and that's pretty much what it is. So cosine theta, I'm going to leave, but I know that secant is 1 over cosine, so I'm going to make that substitution. And all right, I'm a little surprised. I thought I was going to get a cosine squared, but these cancel. So what I'm left with is sine squared theta minus 1. Now you may be disappointed, but remember, we can manipulate the Pythagorean identities a little bit with our adding and subtracting on both sides. So if we're given sine squared plus cosine squared equals 1, the question you could ask yourself is there a manipulation you could do to this identity to get this? And there certainly is. If you subtract a 1 from both sides and you subtract a cosine squared from both sides, you have this. So sine squared theta minus 1 is cosine. So that is the simplified form of this example. So what I want you to realize here is, even though you have these Pythagorean identities given to you, you can't only look for them in this form. You got to add and subtract from both sides and manipulate them. Then in example 4, once again, I notice a hint right here. I see a plus sign. So I know that I could possibly be heading for this trig identity we just worked with here in example 3. So I see that I have sine times tangent plus cosine. Let's see if we can do a substitution here with this tangent that might either cancel this sine or maybe give us a sine squared. So on the quotient identities, I see that tangent is sine over cosine. So let's make that substitution. Put in sine over cosine plus cosine theta. And notice I have my bad habit here again of not always putting the theta in, but we realize that it's there. So sine times sine is sine squared theta. Now I have cosine theta in the denominator, and I'm adding to that cosine theta. And it appears that we have come to a dead end because I can't add these. So this is where we have to get creative. You still need to remember your skills that you learned in 3rd or 4th grade of common denominators. I would like to be able to add these two fractions, and I can only do so if we have the same thing in the denominator. So you need to ask yourself, what could we multiply this cosine over 1 by? What could we multiply it by to get a denominator of cosine? And remember, you have to multiply it by something that has a value of 1 so you don't destroy the value of this fraction. This is cosine over 1 and it has to equal that. So if you do some thinking and you realize we need a cosine in our denominator, so if you're going to multiply the bottom by cosine, you absolutely have to also multiply the top by cosine. So I wanted to give this example to you to put this in your skill set. When you're working with these, you have to be able to multiply by 1, however, in whatever form needed to get us where we want to go. So here, cosine times cosine is cosine squared, and 1 times cosine is cosine theta. And what I have done is set myself up to add these with common denominators. So now I can add my numerators. Sine squared theta plus cosine squared theta all over cosine. And once again, we will use this identity because sine squared plus cosine squared is 1. So this gives me 1 over cosine. And just by definition, from the reciprocal identities, 1 over cosine is equal to secant. So when this is all said and done and simplified, the answer is secant theta. All right, I can't wait to have fun with trig identities. Can you?